Okay, we will continue with the equations that we are going to use in this section. We are going to use, girls, the same equations that we used in the previous chapter. This 1 over p plus 1 over q equals 1 over f. Recall that p is the object distance, q is the image distance, and f is the focal length. Now, this is not called a mirror equation because we are not talking here about mirrors, but we are talking instead about lenses. So this is called thin lens equation. Why it's called thin lens equation? Because we here assume that our lenses all are thin in order for this equation to work. Okay, because, girls, I told you the third ray, which is the ray that passes through the center, it only like goes without any refraction only if the lens is thin. Okay, and the other one is the magnification equation. Magnification equation, it's equal to the image height over the object height. The same thing, and it has two ways. We can write it as this, or negative q, image distance over p. Here, girls, I want you to focus on something now very important, which is the sign of these quantities. Okay, so at the beginning, I want you to note that the front side of the thin lens is the side of the incident light. Okay, because, girls, here we have lenses, not mirrors, so we can place our object on either side. Okay, so when I say the front side, I mean the side where the incident light is present. Okay, so the front side of the thin lens is the side of the incident light, wherever the object is. Like, for example, this is the converging lens. If your object is here, okay, the ray is coming from here, so this is the front and this is the back. But if this is the converging lens and the object is here, so this is the incident light, so this is the front and this is the back. But usually we use this one, so don't confuse yourself. A converging lens has a positive focal length. Okay, so a converging lens, girls, we talked about it before, this one. The focal length is from the optical center to the focal point. This is the focal length, and it's always what? Positive. So on this side, whatever you have on this side, the distances here are positive, girls, because this is the real path of light. The light for lenses will continue to the other side, not like mirrors, it will not bounce back. So the rays, the real path of rays is here. The rays, they should continue their path to the other side. So here this distance is positive. So this is the focal length, because the rays passing through converging lens, they meet at this point. Okay, now let's talk about all the signs here. Girls, this is the image. Okay, this is the image. So this is what here? Q, right? Because Q, it's the distance from the optical center to the image produced. So what do you expect here? Q is positive or negative? So Q is positive. Okay, so here all the distances are positive, where the real refracted light is. What else? What do we have here? So Q is positive, F is positive. What about the magnification? Is it positive or negative? So for sure it's negative. Since what? Since it's upside down. How can we, girls, prove that? See, magnification, it is negative Q over P, right or no? P here, we assume that always it's positive. Okay. What about Q? Since we said here Q is positive, so this is a positive number, and here I have negative sign, so the answer will be what? Negative. Okay, and I can also prove that from the other equation of magnification, which is h prime over h. What is h prime, girls? H prime, it is the height of the image. See, the height of the image, is upside down, so h prime is negative. and h, since the object for sure is upright, positive. So magnification is what? Negative. Okay, what about the size? What do you expect? The magnification, is it more than 1 or less than 1? Since the image here is smaller than the object, so magnification is what? Is less than 1. So the same thing with mirrors, okay? The same thing, but here pay attention on the signs only. Now, in this case, okay, what about the focal length? Since we have converging lens, so for sure we have the focal length is positive. What about Q? What is a Q? Q is again the image distance. What means, girls, it is the distance from the optical center to the image, okay? So also it's what? It's positive. Since it is the image produced, it is on the same side of refracted rays, the real path of rays. So Q is positive. What about the magnification? Since it's upside down, so for sure magnification is negative. What about the value of magnification? Is it more than 1, less than 1, or equal to 1? What do you think? So for sure it's equal to 1 since the image has the same size of the object. Now case number 4. The image produced is here, okay? So what about the focal length? So for sure the lens is converging, so focal length is positive. Q is positive also. Q is positive, the image distance, okay? The magnification negative since the image is still upside down. And what about the magnification now? The magnification is more than 1 because the image now is bigger than the object, okay? So girls, for sure you notice that when the object like becomes closer to the lens, the image becomes what? Bigger. Okay, here no image, so we don't talk about Q. Here the last case, number 6, pay attention with me. The focal length for sure for converging lens is always positive, whatever the image created is. Focal length is always what? Positive. And that's why sometimes converging lenses are called positive lenses. Okay, now we will talk about a Q. What is a Q? Q is the image distance. It means distance from the lens to the image. Where is the image? It's here. So what do you think now? Is it positive or negative Q? Q here is negative. Why? Because Q here is formed on the side where like the apparent path of refracted rays is, not the actual path is. So here Q is negative, okay girls? So pay attention, Q is negative in this case where the image created is here. Now what about magnification? If I want to talk about the value, it's very clear. The value is more than 1 because the image is bigger. If I want to talk about the sign now is what? Magnification is positive because my image is upright. Okay, for sure we can prove this from the equation. What is the equation? Negative Q over P. Okay, so CP positive, but Q here is what? Negative. Negative times negative, so it gives you the answer positive. So that's why magnification always positive for virtual images, because virtual images are always upright. For diverging lens, now for diverging lenses, what about the focal point? Now the focal point is the focal length is negative. Why? Pay attention with me. This is the focal length. So the focal length, girls, here is the distance from the center to the focal point, the principal focus. And the principal focus here is made by the apparent path of light, not the real refracted ray. So this focal length is therefore negative, and that's why sometimes also diverging lenses are known as negative lenses, because their focal length is always negative. So pay attention. In any question you have diverging lens, you have to know alone that the focal length is negative. Okay, I will not give you in the exam that focal length is equal to -9. I will give it as 9, but you have to know the sign, since I mentioned the word diverging lens. Okay, so for diverging lenses, always focal lengths are negative. What about Q? See, girls, the image is always produced where? here in this side, sorry, here is the image. Okay, here is the image. Okay, so Q also negative, because as we said, the image created here made by the intersection of the apparent path of refracted rays. What about the magnification? Magnification, it's very clear, it's positive because it's upright. What about its value? Its value is always less than 1. So for diverging lenses, we have fixed characteristics. They won't change because we have only this case. Okay? So these are the signs. They are very important, girls, because you will use them in the problems. Okay? Here you have summary about them. And here this table also you have summary about the signs. This is everything about converging and diverging lenses. Hope that you understood everything.